Well, Visual Studio 11 really is an advanced development environment. We've done a lot to make sure that the core IDE is really first class for developers and taken a lot of feedback from developers on things and changes that they wanted to see. We've done a lot of work around one of the chief complaints from software developers, and that was project and solution file compatibility between versions of Visual Studio. The reality is many developers have to work in multiple versions of Visual Studio depending on the projects or solutions that they might be working with. And it was a big stumbling block when developers had to share artifacts between different versions of Visual Studio because the project files or solution files would always get upgraded. We fixed that in Visual Studio 11, and now you can open up an existing project file without making modifications to the project file or solution file. And that gives you good compatibility back and forth. We've also added a lot of integrated packaging into Visual Studio to make it easy to distribute your applications. One of the things that we've been asked for some time is can we plug in or can we have great support for various testing frameworks as part of the Visual Studio environment. And there are a lot of different testing frameworks out there. In Visual Studio we've had for the last few years a testing framework called MS Test. It was managed code only, and it shipped with pretty much all versions of Visual Studio. But there's a lot of other testing frameworks out there and mocking frameworks as well. And so we've done a lot of work to re-architect the testing or the unit test capability in Visual Studio and allow you to plug in essentially other testing frameworks like NUnit or MBUnit. Additionally, we've done a lot of work around supporting both managed code developers and native code developers. So in this release of Visual Studio, we've actually included a version of MS Test for doing native code unit testing as part of the core package. What you'll find throughout the Visual Studio toolset is that many of the features that used to work only for .NET or managed code before have now been updated to work the same way with native code. As you're building DirectX apps or native Metro apps, and you want to use C++ as a language, you'll get all that great support that .NET developers have had for quite a while. As you target different machine architectures and different device form factors, it's often not feasible to have all of those device form factors at your disposal when you first start development. So we've done a lot of work around the device simulators to ensure that we have full device simulators in the box with sensor support or simulated sensors, so you can actually test how your application will perform with different sensor inputs like the GPS sensor or the rotation sensor to see how your application actually works without having to work with that device. And to ensure that you can collect data about what's happening on that device, we have remote platform collectors as well that can reach out to those devices and pull diagnostic data back for the user. Now, one of the cool things about Visual Studio 11 and the .NET languages is that we've taken a lot of steps to ensure that it becomes very, very easy to write highly responsive code in the IDE. One of the problems with writing highly responsive code was the complexity and the nonlinear nature of having to use asynchronous calls and delegates to handle callback methods from those asynchronous calls, which made it a little bit challenging to write the code, a little bit disjointed when you were reviewing it and debugging it. With the focus on asynchronous methods, particularly in the Windows runtime for Windows 8, a lot of work was done with the core languages and the compilers to make it a lot simpler to work with asynchronous code. We've added keywords like the async keyword and the await keyword, which can be used in your code to indicate that a method is asynchronous by default and that it can await on asynchronous responses, immediately returning code control back to your application so that it can do other processing instead of locking on a particular thread like a UI thread. The beauty of it is asynchronous code looks and feels just like regular synchronous code. You write it top to bottom. You don't have to worry about delegate functions and callbacks. The compiler takes care of all that work for you. Let's take a look at that. Okay, in this example, what we're going to use is a very simple case. We're going to take a large file from a website and download it to our local C drive to demonstrate the impact of using async versus not using asynchronous methods, and to show how easy it is to do that with Visual Studio 11 and some of the language enhancements. To start off with, in my Visual Studio solution here, I've got a very simple ASP.NET web application, a web forms application, and on that application I've got a fairly large file called isofile.iso, and to get us started for running this, I'm simply going to go ahead and view this in the browser, and this will bring up a standard ASP.NET template, but the file is now hosted on our local PC. Now, to actually show what we're doing here, we've got a very simple Windows Forms application with a button and the button event handler. The button event handler simply calls download file, and when that returns, it's going to change the background of the form to a different color so we can quickly see that it's completed. The download file method is very straightforward. We're not using any asynchronous code. It's simply going to check to see if the local file exists on the C drive, and if it does, delete it. And then go from there. It's actually going to create a new web client and download the file to the local C drive. So let's actually see how that runs. I'm going to just start a new instance of the application, and we're going to click the button method here. Now notice when I click the button method, I can't do anything with the form. It's absolutely locked, and until we actually get the return from that synchronous call, which shows that we're blocking the UI thread. We're doing a lot of nasty things to the application. So how would I fix this to make the application more responsive? And of course this applies to a number of different scenarios, from browser-based applications to rich client applications to device applications. Well, obviously I want to use async. So to do that, I've got Visual Studio 2010 beta here connected to my TFS service running up in the cloud, and I'm simply going to open up that exact same application that we're working with in Visual Studio 2010 and look at it now in Visual Studio 2000 or Visual Studio 11. So here's the application we looked at before. Here, what we've done is we've created a very simple application, same idea. There's a button event handler, but what we're doing now is we've changed our code a little bit. We're calling download file async. We're following best practices to name our method after an asynchronous method so that we can work with it. And you'll notice that in the method handler, we've got an async keyword there to tell Visual Studio and the compiler that this is an asynchronous method and that it has to do some special stuff for us to make sure that the code works correctly. Now, in our line of code where we worked before, we're still creating a web client like we did before, but you'll notice here that I'm calling the await keyword, and I'm also using the task parallel library, and I'm using a method called task.whenAll, and task.whenAll will allow me to execute some code. In our case, we're calling the download file async method, which is an updated method that comes with the Framework 4.5. And in this case, you'll notice the IntelliSense shows me that this method is awaitable, which means that it is asynchronous and works with the await keyword. And you'll notice that throughout the IntelliSense in Visual Studio, any methods that work with async will normally have the awaitable to help you identify those. Now, in this particular case, we're calling the async download, and we've decided to do what we call a continuation task. So once that's done, we're using the continue with, and we're telling it that we want to do, we're going to show a message box saying we've completed downloading the file now. So let's actually see what happens when we run this application versus the last one that was synchronous. So I'm going to start a new instance of it, and we'll see it pops up just like the other one. When I click the button one method, you'll notice now the application is working just fine. It came back from the async method, but now when we've actually completed downloading the file, I popped up a message box to say that we've downloaded the file. And you can see that the application was responsive. It didn't didn't lock the UI thread, and I can continue doing other stuff with the application while I'm awaiting a long-running operation. And that was simply by using the async and the await keywords at a high level to make sure that we're telling the compilers that this is asynchronous and that it has to do special stuff for us. With the introduction of Metro and the new device form factors, there's a lot of focus on making it a lot simpler to write native code as well as high-performance 3D code, particularly targeting DirectX and using the parallel capabilities that is inherent in the modern processor architectures. Visual Studio for a long time has been a great tool for writing DirectX code, but oftentimes people have had to invest time and money in learning other tools to help them work with basic functionality inside of Visual Studio. For example, working with design time assets like meshes and textures has often required that you work with an external tool to fine-tune those. To work with high-level shader language, for example, you've often relied on a different UI or a disconnected experience. So one thing we've done in Visual Studio is really focused on bringing those experiences into the UI, giving you integrated graphics tools and integrated graphical debugging tools. You can debug, for example, graphics processor unit or GPU executed code just like you would debug local processor code. Even linking the GPU events with your source and assets to make sure you can see why something happened and what it was doing. On top of all of that, we've done a lot of work to make it simple to be able to use the massively powerful graphics processors that are becoming available to actually perform complex and oftentimes massively parallel operations. By using the C++ language and the AMP framework, you can actually make use of the GPU to perform various parallel operations on a massive scale, offloading that work from your core processor and giving results back faster. And of course, Visual Studio has been evolving with the support for the parallel debugger, a great debugger for working with parallel code development, and other tools in Visual Studio, including the code analysis or the profiler, also support looking at concurrency as a view on the code. In this example, I'm going to show off some of the new features in Visual Studio for DirectX developers and game developers. I've loaded up a sample game called Marble Maze, and the game is written in C++. It has a number of artifacts available inside of it, including PNG files for textures. We've got media in here. We've got some SDK mesh files, for example, which I can look at and play with. And I'm actually going to go ahead and start debugging this. If we notice that under the debug menu, there's a new mode for graphics. And I'm going to start diagnostics on the application. This will bring up the application as normal, and I can work with the application. The game is currently paused. But if I switch back to Visual Studio, I can actually go to that same menu and capture a frame of the application. From here, I can see the frame of the application. I can double-click on a particular part of the application, and I can see the graphics pixel history. I can see whether rendering alpha is on, and I can actually drill into a particular request. I can also see the graphics event list and take a look at all the events that occurred as I was working with my application, and I can jump into any one of those events and see exactly what happened with the vertex buffers, for example, any shader resources that are using, any states, everything to do with the application itself, and understand more about how it's rendering. I can also look at the object table and see all the individual objects in there, and actually look at, for example, the actual individual objects that are available for me to work with. I can see the pipeline stages for rendering, and to do that I need to find a draw event in the graphics event list. So I'm going to actually go up here and I'm going to just type in draw, hit enter, and I'll select a draw event, and here now I can actually see the stages of the graphics pipeline, where the vertex shader, the pixel shader happened, and I can actually inspect it, look at it, modify it, and see the actual output or the merger of that information right in there. So a lot of very cool features for game developers to debug their application, understand what's going on as they're working with Visual Studio. Let's also take a look at some of the mesh tools that allow you to work with and manipulate 3D objects. In this solution, I've got a sample mesh that I downloaded from TurboSquid actually, and it's in 3D Studio format. If I double click on it, it will bring up the mesh. I can look at the do advanced scripts. I can render it. I can look at debug mode. I can manipulate it. I actually have shaped toolbars and materials that I can play with, so I can actually make changes to the mesh in real time, save my results out, and start to use that object in my game. I can certainly do the normal things like rotations, zoom in and zoom out, with all the capabilities that one would expect in Visual Studio. Of course, building Metro-style applications is a big focus in Visual Studio 11. Metro-style applications are the native application types for Windows 8. And of course, to support that, we needed a whole new set of design surfaces and editors to be able to make it easy and effective and efficient for building these new style of applications. So we've created new designers for all Metro-style applications that allow you to create and reuse resources. The designers are configurable during design time. And to support applications that might be written with the XAML markup, perhaps using C# or VB as a code behind language, we've created a XAML editor with IntelliSense support to make it really simple to write XAML for your UI. Now, to do this, we could have re-architected Visual Studio to support a new design surface, but given the popularity of using Expression Blend for the design workflow, we took the cue of reusing the design aspects or the architecture with Expression Blend around things like object creation, layout, and property editing to make the experience consistent no matter which tool you decide you want to use when building your Metro-style applications. Of course, Blend has been updated. There's a new version of Blend that will be included with Visual Studio versions. It's called Blend for Visual Studio, and it is a special version of Blend built for building Windows Metro-style applications, but not for building websites. So Blend works with HTML, but specifically for building native HTML, CSS applications with JavaScript behind the scenes. So there's no platform abstractions or anything like that. And the idea is you can use Visual Studio as your development workflow engine, but if you want to use a designer engine, a designer tool, Blend is a great tool for rapidly building the UI. And then the two tools work together with similar artifacts. So I can move back and forth as I see fit between Visual Studio and Blend for Visual Studio to do rich visual authoring that'll generate dynamic JavaScript UIs. So very powerful tools here for the developer. A lot of enhancements have been made into the IDE for HTML and CSS developers. Obviously, a big focus on JavaScript tooling as well as the HTML tooling with new HTML5 and CSS code snippets that make it a lot quicker to edit a markup and CSS. As well, you can encapsulate a batch of markup into a user control that allows you to reuse blocks of artifacts over and over again much more effectively than having to reauthor the same content over and over. To make it really super productive when you're working with HTML and CSS, we've done a lot of work around the code editor itself. For example, when you start editing a line of markup and you start putting in a start tag, as soon as you close that start tag, we'll match that with an end tag for you and we'll keep them in sync so that it's very simple to start writing code very quickly. Other things like smart indent and outlining and comment-uncomment support for HTML and CSS are big wins for developers, being able to get the type of capabilities that used to be only available for C# and VB.NET users. Of course, better IntelliSense, including IntelliSense for code nuggets within attributes, a lot of new triggers for that, and the ability to auto-reduce your files. So if your HTML, CSS, JavaScript application includes a number of JavaScript libraries that you want to bring down, we can be smart about combining those and minifying those so that we reduce the number of requests going back and forth between the client and the server to pull all those different artifacts down. It makes it much quicker. A lot of work on the DOM Explorer, being able to inspect and modify the live DOM in IE, style tracing for cascading style sheets, so you can actually start to work with CSS effectively and see the impact of various styles being applied to your elements, and actually look at the layout and debug the layout effects graphically so you can see the impact of your CSS, your markup on your layout in real time. A JavaScript console as well is available to allow you to interactively work against the page. There's a console API and lots of capabilities with that as well. One of the most compelling new features for developers who are building web applications is something called the Page Inspector. It's a new feature in Visual Studio that brings together the browser tools, ASP.NET, and source code into one single experience for troubleshooting an application, inspecting an application all in one shot. You can diagnose issues with your web application, projects, websites, and essentially pinpoint in real time the source code behind a browser selection with just a simple click. You can also use this to reverse engineer other HTML, CSS, JavaScript in the browser to the actual source files to make it easy to understand how a page got put together, to learn from existing pages, and to reverse engineer stuff for advanced debugging work. The Page Inspector is a really powerful tool that has a number of different modes, and let's take a look at that now. Okay, so in this example, we're going to take a look at a new feature of Visual Studio 11 that's really exciting for building and debugging web applications, and that's called this Page Inspector. Here I've got a demo application called the Page Inspector Web Forms demo, and it's got a photo gallery website, and it's an ASP.NET standard web forms application. What I'm going to do to start the Page Inspector is actually right-click on the default ASPX page, and I'm actually going to choose to view it in the Page Inspector. And what I'm going to do now is take a look at the elements of the Page Inspector and kind of show you around. The first thing is it's going to check the page for particular problems, and we can click on that to see if there are any problems with the web.config, look at prerequisites, and of course we can see what the browser would normally show, and the URL that it's using for that. And I can type in my own URL, which is interesting. And as I go through and look at the code, we're basically able to run the code like normal. We can see exactly what the application is going to look like. But interestingly enough, as we go through the code, we can see any particular errors that might come up. And we can see the problem here, for example, there's no mapping data that was returned from the server. And that's absolutely fine. So let's actually stop this one. I'm going to close that. And we're going to go back and start another session here in the Page Inspector. We're going to look at another feature of the Page Inspector called the inspection toggle. And as I click on that and move around on my page, what's going to happen now is we're going to actually see a synchronized view of the page with the ASP.NET source code, the designer preview in Visual Studio over on the right. We'll also see, down in the bottom, we'll see the HTML markup. We can actually inspect the CSS styles and see exactly what's happening in the CSS styles. And of course, any point in time, really interesting here, we can make changes to these CSS styles. So for example, I can right-click on this. I can see where that is impacting. I can uncheck that and take that element off and see the impact of that. And as I go through, I can make changes to my page, and we can see the impact in real time. We can, of course, do the same with code. As we go up into the code, we can look at, for example, the content placeholder. We can take a look at the header, for example, and you'll see that it's menu 1, and we can change the text of it. Maybe my home here in the code, and you'll notice that right away it's recognized that we have a change, so I can click, and it's going to update the page inspector to show me that in real time. So very cool stuff for actually working with an application. If we have to rebuild the application, you can trigger that rebuild. You can certainly even look at things like layouts and sizes to understand where your particular elements are going to sit. Lots of great capabilities here to help you build and work with web applications in Visual Studio. Of course, one of the more common ways in the industry today of building dynamic web applications is to use a combination of ASP.NET and markup that displays on your client application's web browser, or the client target's web browser. And a lot of work was focused in this release on ASP.NET and making sure that it produces uses HTML5 wherever possible to produce great outputs. This includes reaching mobile devices, where we'll automatically generate optimized views and pages that match the device type. For example, we can distinguish between a slate form factor or a tablet form factor and a phone. And then, of course, things like NuGet and jQuery Mobile, a mobile starter set, and making it really simple to theme markup for a particular mobile experience or a desktop experience. To better support these types of broad devices, if you're building ASP.NET and HTML5 applications, we've done a lot of work around the scripting engine with full support for ECMA script version 5, a lot better experience using things like jQuery, and actually creating jQuery controls like the data grid and putting that in the framework so that it's available to you to use right out of the box. You don't have to go and download external components or write stuff yourself. We really view this as a comprehensive web platform that supports quite a few different application models. For example, MVC applications have been built with support pre-built for AJAX views, which support client-side paging, sorting, web forms. You can debug while running. With the page inspector, you can select something that's running and have it highlight where the code is. All of those types of capabilities really focused on making it a lot better experience producing dynamic web applications that have broad reach and impact. Of course, a lot of focus as well on the team developer, people that work together effectively as a team. A lot of work went into Team Foundation Server and the Visual Studio tools to make the experience of adopting Agile on your own terms and the experience of working and tracking your work much simpler for the developer. We included web-based project planning and management tools that work with different processes, including Agile, Scrum, and CMMI, that allow you to do all of your web planning. You can enter in your backlog of requirements or user stories, actually manage those, build out task lists, everything right from a browser. You can do your stand-ups from there. You can plan for your team's availability, and even look at burn-down charts from that perspective. We've also updated Team Explorer to provide a lot better experience for the developer, focusing them on the work at hand, so they don't have to do a lot of navigating to figure out what they need to do. In the screenshot there, you'll see, for example, the My Work tab in Team Explorer that brings together all the information about the context of what the developer is doing. For example, it might show them the work items that they're working on, like requirements or bugs or tasks. It might show them their pending changes, other work items that have been assigned to them, and even supports code reviews as a first-class citizen. This experience has been extended not just in Visual Studio for Microsoft developers, but also through the Team Explorer components that run inside of Eclipse on both the Windows platform and other platforms like Mac OS and Linux. And of course, a lot of focus on being more flexible and bringing a lot more information back to you when you need it to get the diagnostic details to rapidly fix your application. This includes rich unit testing support with multiple frameworks that you can plug and play with, as well as the ability to very simply capture IntelliTrace data in production environments without having to install a version of Visual Studio on the production server. You can simply walk up with a USB key, for example, or go to a remote session, and we make available PowerShell scripts that allow you to start and stop IntelliTrace collection to do diagnosis on production-enabled applications. Okay, so now let's take a look at some of the kind of neat features that we brought to the team users in Visual Studio 11. I'm going to show my favorite, which is using the new Team Explorer. I'm on the home of my account map application, which is actually a TFS project running in the preview TFS service up in the cloud. And so I'm actually connected to a TFS box sitting on the internet, and at this point I've got this same solution that we used in the Async demo. And in Solution Explorer here, I've got a number of files that I'm going to need to check in and check out. So let me just make a change to this file, which will cause it to be checked out. It was a very trivial change. All we did was resize the form, but you'll notice that it checked it out for me to edit that file. So back in my Team Explorer, I can actually see that I have some pending changes here. The new Team Explorer shows me the files that I've got pending changes on. I can choose to exclude files. For example, the big ISO file that's almost 2 gigabytes in size, I'm not adding to my solution on the network just to save time. And so now I can choose to do a bunch of things with this as far as checking it in. If I go back, before I check in my code, I actually might want to get someone else to take a look at this code and provide me with feedback. So what I'm going to do here is I'm going to request a code review. And this is going to allow me to have my edits to the code, my latest changes, reviewed by a peer or someone else on my team, and provide me with feedback. So I'm going to select from the set of users that are on my project a user that's there, and I'm going to add them as a reviewer to the project. And I'm going to enter a subject. Can you check my async code, please? And I can enter more details or send a more descriptive information, but I can simply now submit the request, and now TFS is actually notifying that user and is going to show them that in their My Work tab in TFS that they have a pending code review that somebody wants them to accomplish. So one of the things I'm going to do right now, I'm just going to pause this and we're going to sign in to TFS using that account. So now I've reconnected to my TFS as another user, the AtomGA US user, and I can see in my work, in my Team Explorer, that I've got a bunch of work, got some in-progress work, I've got nothing suspended, but I do have a code reviews and requests request, and here you can see that code review. So I'm going to actually double-click on that, and I'm going to bring it up and see, well, let me see what, I'm going to accept this code review request, and I'm going to open up the files, and here we can see that we've got the different files that are part of our application are listed there, and I can actually go through now and take a look at the actual files and do the code review on those particular files. So here I've got one file that's listed. I can actually expand that out and see that I can see the differences in the file. Of course, this was just a resize of the form. I can see that side by side if I want. As well, in the differencing view, I can actually change my view. I can add comments to this by selecting the code, right-clicking, and adding a comment directly here and say, yeah, all you did was change the form size. Is this right? And I can save that comment, and that will be part of my code review going back to that user. The diff merge viewer allows us to skip to the next comment, previous comment. I can see files side by side. I can even look at the code in line and see the differences between the original file and the new file right in line to make it very simple. And I'm going to send and finish this code review, and I'm going to say, it needs a little bit of work. and that will now go back to that developer. Now if we want to see that, let me just pause this video and we're going to sign in with that user to see the result. Okay, so here I am back in my Team Explorer, and if I go back to my work, I'll see that there are no code review requests, no available work items. Everything seems to be good. Let me see if there's recently finished code review available, and you can see right there, this is the code review that we just looked at. I can see the comment that it's finished, and if I double click or I just single click on that comment, it will take me to the code and I can see what they're talking about. And of course I can reply and do all that workflow that I would normally do. So this is really cool stuff for teams of developers that want to do pure coding, and the fact that it's built in using Visual Studio and TFS means you can rapidly add this to your workflow to make your development experience all the more fun. So we've only touched the tip of the iceberg with all the great new things in Visual Studio 11, and there's some next steps for you. First, you should download and install the Visual Studio 11 beta. It has a Go Live license that allows you to build production code. It's supported. It has a supportable upgrade path to the release code, and it can run side by side with previous versions of Visual Studio, all in the same box. You might want to also take some time and learn about the features we talked about today, and a whole raft of new features also available about Visual Studio. And there's a whole bunch of information, including videos, hands-on labs, and documentation up on MSDN. And we ask that you test it out with your existing Visual Studio 2010 solutions. Visual Studio 11 can open up previous solution files, open it up, build your solutions, make sure it works, be ready for the next wave. And of course, last but not least, as with every Microsoft product, normally as we bring a new product to market, there might be some pricing changes, and that will be the case with Visual Studio 11. So if you are looking to acquire a version of Visual Studio or upgrade to a higher end version of Visual Studio when Visual Studio 11 ships, it's a great time to actually do it now and save yourself some money. So there's a link there to a sales campaign that's available for you to take advantage of to save money now and lock in lower prices for the newer version.